Hi everyone, Zach here, and welcome to Lesson 11 in this series on developing a survival game. In this lesson, we'll create our inventory, and we'll create the function to add non-stackable items. This series has been brought to you by my Patreon sponsors. That said, open up your project, and let's get started. Hi everyone, and welcome back to the editor. In today's video, we'll be working on the first part of our inventory system. And as I explained in the last video, there were a few ways I could approach this. I could have done this entire system in three different orders. I could have done it in the order in which I developed it, which would be very, very painful to go through and double the length of this set of videos. And we already have, I think, 13 videos planned for this section. I could go through the order in which I would make the system or recreate the system now that I know my system, which you will not learn anything from. And then we have the other approach. So the first one is a good option, just really long. The second one is a bad option. The third option is sort of an intermediate between the two. We're going to do this in an order of a logical progression of events. So that said, what we're going to do is go into our content, go to your survival game, go to core. I don't know why I was in character. Go to actors, and we're going to create our second folder here, and this will be inventory. All right, in here, we're going to create a new blueprint class. It will be of type actor, and it will be BP inventory. I'm just going to Control S save everything, and hopefully we'll have no engine bugs that make me re-record this entire video. First thing I'm going to do in my inventory is I am going to disable actor tick. So start with actor tick enabled, mark that as false. We do not need this to tick. The second thing I am going to do is delete my event begin overlap. We are not going to have an overlap event, and we've just disenabled tick, so they can go bye-bye. Next, we are going to create two variables. And one of these variables is, again, our actual inventory. So if you remember what I said in the last video about what our inventory actually is, this is a hint. It's that. It's really just that at the end of the day. We're going to create a variable that's going to store that information. So this will be inventory slots, plural. Remember my little rant about it not being plural when I accidentally made the structure plural? I am not editing that out, by the way. This is why it was singular there and plural here, is we're going to have all the slots here. Insert joke. So we're going to search for F inventory slot. I got to be really careful about how I say that word now. And this is just one right now. We only have one of them. We want many. So we want to click this little blue tic-tac thingy and find the grid pattern one, the one that says array, and select that. This is where we are storing our inventory. So if we can compile real quick, we can see that we have an array. I mean, there's no items in it, but we have an array. So that is actually our inventory itself again. And this will be our inventory settings. And we're gonna create one more variable, and this will be our beginning slot amount. This will initialize how many slots in our inventory we have, and this will be of type integer. It will not be an array. It will not be many integers. It will be a tic-tac integer or a single variable integer. I am not going to continue with that joke, by the way. And I am actually going to default this out to 10 if it will let me click in the spot I want. This will also go into our inventory settings. Next, what we're going to do is we are going to set the number of slots at the very start. Sorry, I'm trying not to cough. What I mean by that is right now there are 0 elements in here. We don't have a size to this. Sure, we could dynamically add things over and over and over again, and I just wouldn't do that, by the way. I would always, even if you are going to have an infinitely expanding inventory system, always start with a fixed number of slots. You can just keep adding slots as you go. And I'll show you where you can later in this video as well. So we're going to create a function, and if you are using that approach where you can add slots, you just recall this function, where we take our inventory slots and we just pull off of here and we resize it. All right. And you actually would have to add an extra step for that to work, but we'll talk about that in a moment. Plug the execute pin into the event start. Notice I've tucked the inventory slots data under our resize. And I'm going to get my beginning slots amount and just plug that into the value at the bottom there. And I'm just going to move this over to the side for a moment while I select these two nodes. I'm going to collapse them to a function, and this will be set number of inventory slots. So on begin play, when this blueprint, when our inventory initializes, it will run this event, and it will set the number of slots that we have at the start. I'm going to just break that for a moment. And the reason why we don't hard code this in is if you do want to increase the size, well, you're just plugging something into here. And resize will set it to a specified size amount. So what you could do is do a an integer plus integer. So the way you're actually going to do that, if you do want an infinitely expanding inventory, is you would get your inventory slots data, and you would find the size, length. But there are other routes to that as well. I'm actually just doubting what I said. But you would take the return value of that, and you would add in whatever you plug in here. All right, now that we've done that, we can get to the main sort of thrust of what we're going to focus on today. And I'm sure I've eaten up like 6 minutes of record time already. So we're going to create a new function, and this is sort of our master function. Everything that we care about happens in this function. That said, it will be calling other functions. Also, this is going into inventory settings as well. So let's make that new master function. And this is add item master. Add item master will be a utility function because this is how we actually get use of our inventory system. How we add, remove, actually how we add items. There'll be a different thing for removing. We will need 2 arguments, so 2 inputs. And the first will be our item class. Again, carefully do BP item master, and you can ignore the test from the last video. If you want, you can try doing a soft class reference. I am going to use a hard class reference here. And the next variable we want is our amount. This is how many items we're adding to our inventory, and this will always be of type integer. So if we just pop back here and take a look at our test item, hello cube, we have 1 that we want to add. This could be 12. We want to add 12 of those cubes on pickup. So this is that amount there. We're going to store this information in a local variable. As I've mentioned in the prep video, a local variable only exists in the scope of where it's being called. So this function, which I know is only 1 node right now, this node only exists for the length of the function. The second we do a return, this gets cleared. It ceases existing. All right, now that we have class local, we're going to do the same thing for our amount. We're going to make a local reference to this, and this will be our amount local. All right, now, in today's video, what we're really going to focus on is when we have a non-stackable item. So this is going to be a polymorphic function. We will take care of stackable items. We'll take care of non-stackable items. Yes, there is some nuance in that, though. What happens if you have a bunch of non-stackable items you're trying to pick up at once of the same type? What happens when you have no stack for your stackable items? It's available. What happens if you have more items than your stack can handle? Well, we have all of that accounted for in this function and its child functions. I don't use child in the sense I talked about inheritance in the last video. What we're going to do is we're going to get class local. We're just going to put it to the side because we're going to create a macro. Now, you don't need to make this a macro. I just make it a macro for ease of reading, and so it's easier to follow because I don't then have to remember that true is stackable and false is non-stackable. So we are going to get our class defaults. Get class defaults. We are going to get our item details, and we are going to break our item details. I'm going to select the class default and hide unconnected pins. By the way, as a side note, I just realized something. When you do this in the future, or when we go further into this later in the video, later in the series, you're going to need to come back and rehide those unconnected pins because we're adding something to our class defaults down the road. All right, open up the break item details, and we want the is stackable, and we're just going to do a branch. Select this, hide unconnected pins. You won't have to re-hide the pins in there because we're not adding anything else in there. Plug that into there. So if this is true, it's stackable. If it is false, it's a non-stackable item. I am just going to move the break and class defaults to the side. As I said, I'm going to make this a macro because I'm taking advantage of the fact that I can have multiple execute pins in a macro. And I can name them whatever I want. So collapse to macro. Again, you don't actually need to have said macro. You could just leave it with the true-false statement. And this is check if stackable. I'm going to switch my input and my execute pin and my class pin. And hopefully we won't have to update this to the actual item class, and we can leave it just as class. Sorry, this as an object. I've never tried it. I've always updated it, but I'm curious. We're going to plug the true in. We're going to plug the false in. We're going to rename the true and false as stackable, or whatever the heck I just wrote there. And stackable. All right, it will automatically add a space into the name. I don't know what to say about that. Meh. So now we have a more easily read, all right, this is our stackable branch. This is our non-stackable branch. And suddenly I want snackables. I'm not going to make an American Runs on Dunkin' joke because I still miss their bagels. What we're going to do next is we're going to handle the non-stackable. We want to find an empty slot in our array. So we're going to create a new function called find empty slot. Kind of says what it does on the tin, I guess. Find empty slot. And find empty slot is going to be one of our slot availability. Get out of the way, mouse, so I can see what I'm doing. Availability functions. We will have 3 availability functions. All right, the first thing we are going to do is we are going to do a for each loop with break. We are going to go through our inventory slots, and what we are going to do is the second we find an empty slot, we're going to break out of the loop, and that's the slot we're going to put the item in. So we're going to create some more local variables. We need to get our actual slot because we need to see if it's empty or not. So we're going to promote that to a local. And this is inventory slot local. This is the individual slot that we are currently looking at. All right, we want to know what the index of this slot is. So we're going to do an index ref local. And by the way, you're going to kind of be curious for a while where we set the actual index for this. Let me tell you this now. We set it inside of our widgets at the end of the day. It's kind of, yeah. Actually, technically, we're setting it here, but the actual slot itself, when we see it, we're setting it in the widget. It's a combination of the two. So now that we have this information, what we want to do is we want to check if this slot is free. And the way we do that is first we're going to create a branch. From this branch, we are going to check, if I can open my local variables up, my inventory slot local. We are going to break. From here, we have our class, item class. We are going to take our item class and we are going to go is valid. If this class is valid, then we indeed have an item in the slot. Therefore, the slot is not free. Plug that into there, hide unconnected pins, and tuck this into here. So, if true, slot is not free. Because if it's valid, there is something there. If it is not valid, it's equal to null. The slot is empty. In this situation, what we're going to do is we are going to set our slot index to -1. Because -1 is never a valid slot indice. Remember that in theory, actually not in theory, in fact, every time we come into this function, these numbers are 0. They're zeroed out. They're nulled. Or these values are nulled out. This is just a way of nulling it for ourselves, just temporarily. But it doesn't really matter because we're going to have a bool function that we check first. We don't check the index. We check the bool. If the bool is true, then this number should be valid. So let's create a local bool variable called b is empty local. And again, it's a boolean. If this is not valid, the slot is free. Therefore, it is empty. I'm just going to grab these nodes real quick and line them up. Oh, I missed the one I care about the most. branch there. We're going to set this is local to true. And we're going to then have something really fun to do. We're going to take this execute pin. We're going to go all the way to the left and plug that into the break. And now we're going to make this look a little bit easier to read. So I'm just going to put a few reroutes in. I'm going to put a lot of reroutes in. Let's be completely fair with how this is going to go. And there we go. So I'm going to line those up, bring it up a tiny bit. So we come in, we check the first indice, or the first slot. If it's free, then we mark it as free, and we pass out this information and the fact it's free. If it's not free, we invalidate the slot, we come back in, we check the next slot. We then set this to the next number in our array. The number here, again, is getting overridden by the number here every time we come in. So if at the end of the day we don't find any empty slot, yeah, this will be -1 until we hit the complete, and then it just gets nulled. On the complete, we'll have a return node. This return will return two things. We care, one, is the slot empty? So we're just going to plug into there, and we care what the index of that empty slot is. So again, even if we're passing out -1, we're checking that bool first so that we never try to put something in a full slot. So I'm just going to rename these as isEmpty and indexRef. You will hear indexRef a lot. I will probably call it our good old friend at some point, because I did in one of these recordings. Because, yeah, I'm going to say indexRef just way too many times for my own good. I am not joking. Next, we're going to go back to our add item master. I'm going to close the check if stackable. And in our add item master, we are going to do find empty slot. I'm just going to plug a reroute into there, bring this down here, line this up. And the next thing I am going to do, actually, I'm going to rename these again. It is B found empty slot and empty slot index. That's just going to be easier for me to remember what these are really doing. So again, we're going to check this first. I'm going to pull off the red pin and do a branch, and notice it auto plugs in the execute. If this is false, we are going to fall out of our function here, and we are not going to pick up the item. And we're going to have two returns when this happens. We're going to have, I'm actually going to put both in because one is an integer. The first will be B, successfully added. That B should make it clear this is a Boolean. I'll give you a guess if this is true or false based on if we don't find an empty slot. If you've guessed true, you are wrong. All right, then I'm going to take my amount local, and I'm going to pass that out. And clearly I forgot to rename the second variable, which is amount remaining. I'll explain amount remaining in just a moment when we get a little bit further down our setup here. The next thing I am going to do is I'm going to take my empty slot index, and I'm going to create another local variable called our old friend indexRef local. I warned you I was going to do that. I'm going to plug that into the true, and I'm just going to line that up, put a few reroutes in so it's easier to see where this information is coming from. So even if this empty index is -1, then that should be false, because its default state is false. So we only are setting our indexRef local and our add item master if it has found an empty slot. Next is when we actually add the item to our inventory. Now, this is going to be a polymorphic approach, so we're going to do some things that we will very quickly then undo. So first, we're going to take our index slots data. We're going to get it. We're going to pull off of here and look for set array lm, which stands for element, or if you want to say elm, whatever. You'd be wrong, but whatever. Plug that into the execute. Next, what we're going to do is we are going to hover over our item. We are going to split that structure. We are going to take from our local variables our class, plug that into there, and move that over here. You can guess why these are being lined up the way they are if you know my habits. We're going to take our amount local, plug that into there. And then we're going to take our indexRef and plug it into index. Do not click size to fit. And then we're going to take this node here. We are going to right click it along with the inventory slots, collapse to function. don't worry about the gibberish on screen. Just name this add item. We'll take care of the gibberish in half a second. This is our second utility function. This is what really is adding the item to our inventory. As for our gibberish, let's just leave that first one as index. The second one is item class. And the third one is set amount. Let's unplug set amount from amount local and delete it. Why are we doing that? Well, because we need that pin there for our stackable items. But this is a non-stackable item. We're only adding one at a time. So even if we have multiple non-stackable items of the same type we're picking up, we add one at a time. Now, I haven't explained something yet. I said I was going to explain it as we get to the end of this. But hopefully now it's starting to get clear why we have this amount remaining section. If not, don't worry. I will explain as we get further in. Just going to come into our add item. And I am going to do a return node. All right. With our return node, what we're going to do is head back to add item master. And we are going to put a bit of a space in. I'm just going to say we're putting a space in because this is where our encumbrance system is going to go. So between here and where I'm about to go is our encumbrance system, but I'm going to do a branch. So I'm just going to flag that as encumbrance. I probably spelled that wrong. God knows I was adding extra E's last time I did this. I don't care if it's a typo. So what I want to do here on this branch is I want to check, is the amount local 2 or more? So I'm going to get amount local. Is it greater or equal to 2? If it is greater or equal to 2, then I have picked up multiple non-stackable items of the same type. And if I haven't, the easier one, then yay, I'm done. I'm going to do a return. I have successfully added everything I needed to add, and I have nothing remaining to add. Again, I know I haven't explained that yet, but hopefully I've dropped enough hints between this, and that comment that you've worked it out. Again, if you haven't, don't worry. I will explain it. I just want you to think about it before I do. So what we're doing here is check if multiple unstackable or non-stackable items added or picked up. If this is true, what we want to do is we want to adjust our amount local. Because we've just added one here, we want to take this away from our amount local. So we're going to decrement our integer. Now, here's a thing you should know. See how that shape there is a diamond and that's a circle? Diamond means, as I hover over it, it says on screen, integer by ref. This is a, so this is a reference, this is a copy. A reference is, or copy of the value. A reference is the actual variable itself. When you set a variable by reference, you are setting that variable. In other words, we don't need to plug in amount local here. That diamond is saying whatever's being plugged into me, that's being changed. In fact, actually, if you know anything about C++, you've seen these multiple returns we're doing. You're probably going, wait, how does that work? A function only has one return. It's actually passing a reference in an argument. That's actually what's happening here. This is an argument being passed in. And because we're passing it in by reference, we're changing an actual value. We're changing an actual variable instead of temporarily changing a value when it's in the scope of this. We can pass out that same variable. It's a very cheeky but cool method. And now we get to the part that I talked about in the prep video. But before we do that, I'm just going to do adjust amount to add. So what we talked about in the prep video was recursion. What we're going to do now is call add item master. We are calling the very function that we are currently writing at the end of this. Why are we doing that? Well, we still have more items to add, so we need to go through this entire check again. Yeah, sure, I could just plug all the way back here and redo it, but I don't have a proper escape route. I mean, sure, I would hit this and get a proper escape route. It's just not elegant, messy, and a wee bit confusing. More confusing than just going, I'm calling this thing again. So I'm going to take my adjusted amount and plug it into amount local. And I'm going to take my item class, and we're just going to pass in item class. All right, once this has finished, be it finishing successfully or not, we still have to finish the overall. So we're going to do a return here. You do not plug in successfully added here. This is where it gets a bit confusing. You just mark this as true. You do plug in our amount remaining though. Why? Well, we're done. We are done here. Everything's been taken care of. What's happening is if we don't have enough slots and this is false, we are failing out of here. We don't want to pass the failure when we actually have successfully added the initial item. So this is where it gets, again, a little bit sort of mind trippy. When the first time we call this function, this is just one item. We only care about the one item we've passed in, even if we have to call this multiple times. So when this is called multiple times, if one of them is not successful, that's going to pass out to the item. Hey, I'm not successful for you. Bye. And leave it on the ground. But we still care about the initial item with this return node. It'd be easier to actually draw this out, but yeah. So this is our recursive call to this function. And when I say this function, sorry, I do mean this very function. All right. Let me just make a comment here. Adds item to inventory. And this finds free slot and sets index for free slot. And this takes us through what we need to do in today's video. I'm at 27 minutes, and if we try to go any further, we're going into the non-stackable. That is gonna just be way too long. It's gonna be on itself probably a 30-minute video. So as I warned you, we aren't gonna be able to see all the testable things yet, but hey, we're getting fairly far along in having a fully functional inventory system. The only problem is after this, then we have to create the UI for it. Hopefully we'll be able to do some debugging before then. But that said, we finished everything we need to finish for our inventory system today. If you've enjoyed working on your inventory system, if you're looking forward to having, hi, I'm an item, having your inventory system and then equipment system in the next section set up, make sure to hit that like button. Also, if you want to continue working on the inventory system, make sure to hit the subscribe and notify icon so you know when the next tutorial for this section is out. Hi, I'm an item. And I'm going to stop doing that joke at some point, but it still makes me giggle. And if you want to help support this channel, consider becoming a Patreon supporter. Patreon supporters at Hi, I'm an Item, at upper tiers, get instant access to the project. At other tiers, supporters will get access once the project has completed. I am trying to avoid that cube, by the way. This series has been brought to you by Patreon sponsors like Rian, Quadmenson, and Haynes. All of that said, I look forward to seeing you in the next tutorial, and I hope, you know I'm thinking about it, you have a wonderful day. Hi, I'm an item.